When it comes to clinical trials, the data, well, it's everything, right? But how do we know we can trust that data? It really all comes down to the tools we use. So today, we're going to dive into a super important part of good clinical laboratory practice, the rules for equipment and computerized systems.
So let's kick things off with a big one, maybe the most important question any regulated lab has to answer. How do you prove, really prove, with cold hard evidence that your equipment can be trusted? Because let me tell you, answering that question, that's the absolute foundation for any data you hope to defend.
To really see how this plays out in the real world, we're going to follow a little case study. Let's meet a fictional lab we'll call Apex Labs. Now, they're gearing up for a huge clinical trial. And their success, not to mention their entire reputation, is riding on getting this stuff right from the get-go.
Okay, so the challenge for Apex Labs is pretty straightforward, but it's massive. They have to guarantee that every single data point they produce is accurate, reliable, and can stand up to some serious scrutiny. Think about it. The whole chain of trust for a massive, multi-million-dollar trial, it starts right there with their equipment.
The very first principle guiding every single decision they make is this: all equipment has to be fit for purpose. And listen, this isn't just a nice idea or a suggestion. It's a core GCLP requirement. It means an instrument isn't just on and working, it's been proven to be the right tool for the exact job it's going to do in that clinical trial.
All right, so imagine this. A shiny new analyzer just got delivered to Apex Labs. What now? How do they actually prove it's ready to go for trial samples? Because you and I both know they can't just plug it in and hit start.
Well, they've got a really clear three-step process, and it's all documented. Step 1 is user acceptance testing. This is huge. It's where the lab shows the machine works for their specific needs, right there on their bench, not just back at the factory. Step 2, they document every single successful test result. This creates that all-important paper trail. And finally, the last and maybe most crucial step, they formally certify it for use. They put a date on it, and that marks the exact moment it's officially ready for clinical work.
But here's the thing. Getting it right on day one? That's not enough. Not even close. Apex Labs knows they have to prove that this equipment stays fit for use every single day of that trial. And this is where that daily discipline really kicks in. Apex Labs runs on solid standard operating procedures, SOPs. These are the detailed written instructions for everything, especially things like cleaning. Maintenance isn't just whenever someone gets around to it. No way. It follows a strict, documented schedule. And of course, the big one, calibration. Meticulous records are kept for everything, and every one of these activities is done at a justifiable frequency. It's all about having that constant proof that the equipment is working just the way it's supposed to.
So that brings up a good question, right? How does Apex Labs even decide on that justifiable frequency, especially for something as critical as calibration? Well, they use a risk-based approach. And it all starts by asking a really tough question. If we find a problem with this machine today, how many samples have been affected?
And that question immediately leads to the next one. How long has it been since you could prove it was working correctly? You see, that gap, that's your window of uncertainty. The time between your last known good calibration and the moment you found the problem, that defines just how big your potential data nightmare could be.
And this is where we get to the real stakes. What's the cost to fix this? And we're not just talking about the money to rerun samples. We're talking about trial delays, damage to the lab's reputation. Heck, it could even call the entire study into question. It's by thinking through those consequences that Apex Labs can absolutely justify having a really robust and frequent calibration schedule.
Okay, so we've talked a lot about physical equipment, but these same tough standards, they don't just apply to the hardware you can touch. Apex Labs applies this exact same thinking to all of their computerized systems. I'm talking everything from the software running an analyzer to their big limbs, the laboratory information management system that tracks every single sample.
And what's so interesting here is how much everything lines up. Look at the parallels. The principles are basically identical. The computerized systems, they also have to be fit for purpose. They also need regular maintenance and validation. And yep, they're also under strict change control. The core philosophy doesn't change one bit just because we're talking about software instead of a box.
So for software, this proof has a name. It's called system validation. And all that is a documented process that proves the whole system, the hardware and the software together, is suitable for what you need it to do. This is how Apex Labs can stand behind their digital systems and say, yes, this will give us reliable, reproducible data, and it will keep that data safe.
So what happens when things change? Because they always do, right? Let's say the manufacturer pushes out a critical software patch. Apex Labs can't just click install. No way. They have a strict change management process. First, they assess the risk of that update. Then, they do whatever revalidation is needed to prove it still works exactly as it should. And only then, only after all that, is the updated system formally authorized to be used again in the trial.
Look, we all know that even with the best plans in the world, things can go wrong. It happens. And that's why a huge part of the GCLP mindset is actually planning for failure. It's about having a plan B to protect the data and the trial's integrity, no matter what.
For Apex Labs, this means having documented disaster recovery plans ready to go. It means having clear procedures for any equipment that's taken out of service so nobody uses it by mistake. And this is a big one. It means tightly controlling who has access to computer systems, and then periodically reviewing those access rights to make sure they still make sense. It's all about making sure that data's validity, integrity, and security are locked down always.
So, by putting all of these GCLP principles into practice, and I mean for everything, the physical equipment and the digital systems, Apex Labs has built this amazing, verifiable foundation of quality and trust. It's all right there in the documentation.
So now, picture this. The auditors show up. They walk through the door. Is Apex Labs scrambling? Nope, not at all. Because they can provide a complete, traceable history for every single result, linking it right back to a validated system and a calibrated machine. That documentation, that is the absolute key to a smooth audit and, more importantly, total confidence in their data.
And really, that's the ultimate takeaway here. The whole point of all these procedures isn't just to spit out a number on a report. It's to create a permanent, verifiable, and completely defensible record that proves the quality of the work behind that number.
So I'll leave you with a final thought to take back to your own lab. When you look at your own processes for your equipment and your computer systems, what's one small thing you could improve, maybe even tomorrow, that would make your record of quality just that little bit stronger, that little bit more defensible?